Hello students, welcome back to the series of lectures of Mathematics 1B. Now we were dealing with this chapter of differentiations in so many video lessons. Those who have not watched the previous video lessons, go and check in the playlist of this channel, or else you can also see in the description below. Okay, the immediate previous video of this differentiation where we are dealing with the hyperbolic functions, those video lessons you can check it on the iCard. Just clicking on the iCard you can be notified. Right, now let's quickly start today the solutions for the 9B exercise wherein the hyperbolic functions are involved. We have done this 9B exercise since 2 video lessons. Go check them. Okay, now in that 9B exercise, third section, the first part I have written here. Okay, find the derivatives of the following functions. This is dealing with the inverse trigonometric function. This is not a hyperbolic function. Let me check in the textbook once here. Yes, this is not a hyperbolic function, just an inverse trigonometric function. Okay, here when you see the y function is given in the form of sine inverse of b plus a sin x, a plus b sin x. Okay, there is some other function here again. So let us suppose this as u. Okay, let me take the inside one which is very big. So let me suppose this as u. So u is equal to b plus a sin x divided by a plus b sin x. Okay, so that we can easily derive here. Okay, if I want to get dy by dx, I have to find the derivative of this, isn't it? So I am supposing this function as u. This becomes, so here we can tell that now y is equal to sine inverse of u, to make the function simpler. Okay, now we all know that derivative of this dy by dx, if you are taking x, we have to do it here. The function is u, isn't it? So if you are taking with x, you have to go for dy by du. Again you have to do with the chain rule. Okay, here let us keep this as it is. Now here we will proceed to du by dx. Okay, I am derivating only the u part here first. So the derivative of this is with respect to x. Okay, it is in the u by v, that is the quotient rule. So a plus b, this is v, and the derivative of this, derivative of u is, derivative of b is the constant 0, derivative of a sin x is a, if you take it out, derivative of sin x is just cos x. Okay, minus, and we have to write this. Now we have taken v, derivative of u. Now you take b plus a sin x, and derivative of v. Derivative of v is, derivative of a is 1, b sin x is, b comes out b cos x. Okay, divided by, here I have applied the quotient rule. So this is a plus b sin x whole square. V u dash minus u v dash, likewise by v square. But here I am not taking uv because already we have mentioned this particular as u, isn't it? No, here we are not doing that. Okay, now so this is just du by dx. Later on we have to find dy by dx is the question actually. We should find the derivative of this function, but we have found the derivative of only u function. Okay, now we will multiply this doing the product, a square cos x plus ab sin x cos x. Okay, again multiplying this, minus b square cos x minus here b square cos x, and minus ab sin x cos x. Okay, we can cancel it off. A plus b sin x whole square. So we can cancel these two. So we get du by dx as, when you are taking cos x as common, you can write it as a square minus b square by a plus b sin x whole square. So we have simplified it. Okay, in this form. This is only du by dx, but I want dy by dx. Okay, so let us find y is equal to, so we want dy by dx with respect to x. Clearly see that with respect to x we are doing. So sin inverse u is 1 upon root 1 minus x square, but here x is u, so 1 minus u square. And the chain rule we have to apply, because this is not x, this is u, so we have to do the derivative of u, du by dx. Okay, here du by dx we have found it out. We got this du by dx. We can substitute here. But here what is 1 minus u square? So 1 minus u square means, I'll write it here, 1 upon under root 1 minus u is this one. Okay, so b plus a sin x divided by a plus b sin x whole square. This is the u part. Okay, multiplied by, we know du by dx is this one, the simplified version. This is cos of a square minus b square divided by, here we have a plus b sin x whole square. Right, now we will move on to the other part here. Let me make a partition here. Yes, okay, we will simplify this. Here it is under root and it is in the form of a fraction. So when you do the LCM, this becomes, let me write here, that becomes 1 upon, if you are writing this, LCM part, a plus b sin x whole square minus, this is there, b plus a sin x whole square divided by, we get this a plus b sin x whole square, but it is under root, so square and square root goes, this comes above. So here I can write it as, above I can write a plus b sin x. So I'll repeat it. See here, if you are taking LCM, a plus b sin x whole square is LCM. So this LCM is under root. So if it comes by, it comes above, isn't it? So under root, square root and square goes off, only we get a plus b sin x. So that I have taken it to the upper part. Okay, this square root is there and multiplied by, we do have this. So there is no space here, cos into a square minus b square divided by a plus b sin x whole square. Okay. Right. Now here we'll see what else we can cancel off. See here, this becomes a plus b sin x multiplied by cos of a square minus b square. Cos of a square minus b square, is it? Yes, cos x. Sorry, here cos x is there. Cos x into a square b square divided by, let's open up this. This becomes a plus b whole square minus again a plus b whole square. I will expand it, that is a square plus b square sin square plus 2ab sin x. Okay, 2 into a into b sin x. Again I'll expand this minus, here b square minus a square minus 2ab sin x. So this is all under root. Okay, these two we can cancel it off, and also this becomes b square, a square sin x. Okay, a square sin x is there here. Now what else we can cancel? Nothing will be there, and still this part is there. I'll write it here, cos of cos x a square minus b square, here also cos x. Okay, so a plus b sin x whole square, this is there. Okay, now moving on here, if you see here, this and this goes off, this is 1 and this is 2, you can cancel it off this once. Okay, so 1 is there, and what else are there here? This, okay, write it here above. So I've written this here, so no need of writing here. So this I've written here, again I've written. So cos x a square minus b square. These two are different. Cos x into here. Not of cos a square minus b square divided by here under root, what do we have? Under root a square minus b square. Minus b square. Again plus we can take, isn't it? A square minus b square plus b square minus a square plus b square. I'll take, you take just sine function, sine square x function. If you take, you get b square minus a square. Okay, this is remained here, and still this part is also there. A plus b sine x, just square is gone, only 1 is there. So this is totally remained here. Here we can also take a square minus b square common, 1 plus, right? If you are taking cos x a square b square same as it is, you can take, below you can take, this is under root, isn't it? This is under root. Yes, this goes off here, under root. What else we can take here? A square minus b square, if I take common, here it comes 1, and this, if you reverse it, minus comes out, so 1 minus sine square x. Okay, so here again this is remain, not under root here, sine x. Right, this comes to, from the first identity, it is cos square. So cos square under root it is, so it becomes only cos x. Cos x goes off here. These two also goes off. Okay, let me, if you can see this part. So cos x a square minus b square divided by, here you get under root a square minus b square multiplied by cos x here, because 1 minus sine square x is cos square x, under root that is cos x. Cos x goes off, and still we have a plus b sine x. Okay, a plus b sine x. This part is remained. So here also this goes off, square root and this one. So here you get square root. The final answer, so it has become very tight here. See here, the final answer is under root square root of a square b square divided by a plus b sine x. So this is the final answer. Here square root, here only just this, there is no square root, so I can cancel it off this once, and this is remained. So this is a very lengthy one. Like this we do have 2 more problems. Please pause the video and note it down. So in this section we have second problem similar to the first problems. First problem was sine inverse of b plus a sin x by b plus a sin x, isn't it? The similar way, the second problem was cos inverse of the same thing, b plus sin x by a plus b sin x. Okay, only thing is cos inverse. For cos inverse of any x, we use the function as, we take the derivative as minus 1 by under root of 1 minus x square. Simply we have to keep a negative sign for the cos. So in the similar way of sine inverse, you do the second problem of cos inverse. Okay, now here we will move on to the third problem in that similar way, but it is tan inverse. Okay, for sine inverse and cos inverse, we have the trigonometric functions derivatives as 1 upon under root 1 minus x square and 1 upon under root 1 minus x square with a negative sign for cos, isn't it? But here in tan we have the different one, that is tan inverse. Let me suppose the same thing. This is y, isn't it? This is y. Let me suppose the inside part as u. Okay, let u is equal to cos x divided by 1 plus cos x. Okay, so this is the u part. So we should find the derivative of dy by, if I suppose this as, so dy by, so our, let me write here, y is equal to now tan inverse of u. Okay, I am substituting u, isn't it? So dy by dx with respect to x, not with respect to u. Okay, dy by dx I am doing. It becomes 1 upon 1 plus x square. Here x is u, isn't it? U square. Again, since the function is in u, you should find the derivative of this according to the chain rule, du by dx. Here, see this. In the previous two problems, we had 1 upon under root 1 minus u square and minus 1 upon under root 1 minus u square. That is for cos inverse and sin inverse. But for tan inverse, it is 1 upon 1 by x square here. X is u. So again, with the chain rule, I have to do the derivative of du by dx. Here first, we will find du by dx. Okay, this is u. So let me find du by dx. So the derivative of cos x and 1 by cos x, here it is in the form of u by v, quotient rule. So 1 plus cos x u, d by dx of cos x is minus sin x. Okay, when there is c is involved, you get a negative sign. Okay, here divided by, okay, minus, we have again here v u dash, u here, you should take u cos x, d by dx of 1 plus cos x, that is 1 is 0 and derivative of cos x is minus sin x. Okay, divided by, here we get 1 plus cos x whole square. This is v square. Okay, we applied the quotient rule here and we will multiply minus sin x cos x. Here minus plus sin x cos x. Okay, so you can cancel off minus and plus. This becomes 1 plus cos x whole square. Yes, so we got this. This is what du by dx is equal to, we got it as here minus of sin x divided by 1 plus cos x whole square. This is only du by dx. We have to multiply it with this, isn't it? So let me find out. So we should get here dy by dx is equal to 1 upon 1 plus u square. U is this. So cos x by 1 plus cos x whole square. Multiplied by du by dx is the simplified version of this, that is minus sin x divided by 1 plus cos x whole square. Here we will simplify it. We will take the LCM. So 1 plus cos x whole square is LCM. This comes up. So this becomes 1 plus cos x whole square. That is the LCM part of this. Here you get again 1 plus cos x whole square for LCM plus cos x. So cos square x also you can write cos x whole square or cos square x multiplied by, we get it as minus sin x divided by 1 plus cos x whole square. So we can cancel these two up and down, and here minus sin x divided by a plus b whole square. So a square plus b square plus 2ab. Here I have expanded again cos square x. So this comes to minus sin x divided by, we'll write like it is in the quadratic form. Let us write, see here, cos x cos square x 2 cos square x. Okay, in the quadratic form we'll write 2 cos x plus 1. So this is the derivative of tan inverse of this. First we have assumed the function. In all the three problems the same way, we have assuming this function as u, doing the derivative of this u with respect to x, keeping it aside. Then this is y function. So writing in form of u, you get it as 1 by 1 plus u square. Again for the chain rule you should do du by dx. So substituting du by dx here, we get the entire dy by dx. Do the simplification here. With this we will completed this third problem. Do the second problem as same as the steps of the first problem with a negative sign. That's all. Okay, with this we have come to the, pause it and note it down, and we have come to the end of the exercise of 9b. So those who have not done the 9b exercise and the concept form of hyperbolic functions, inverse trigonometric functions, do check out the description below. You will be getting the links. Okay, we will see with the new concept and with the 9c exercise in a next class. Thank you all.